Hello everyone, we are students of Vishwakarma Institute of Technology and I'm going to be introducing you to our COA assignment. So our COA topic is bus arbitration techniques. So we are group number H7 and we consist of the following group members: Janu, Ishita, Aditya, Om, Jay and Jivan. So our presentation is divided into 5 parts, namely introduction, types, methods, uses and issues. Bus arbitration is a crucial process in computer systems where multiple devices share a common bus for communication. It refers to the mechanism by which conflicting requests for bus access from different devices are resolved in an orderly and fair manner. In a computer system, the bus serves as a communication pathway that allows various devices such as processors, memory modules, and peripherals to exchange data and control signals. However, since the bus can only be accessed by one device at a time, conflicts can arise when multiple devices simultaneously request access to the bus. Bus arbitration ensures that only one device gains control of the bus at any given time, while other devices wait for their turn. The arbitration process involves determining the priority of the requesting devices and granting bus access based on predefined rules or protocols. Overall, bus arbitration is a fundamental aspect of computer system design that enables orderly and efficient communication among multiple devices sharing a common bus.
Types of bus arbitration is first is centralized arbitration and second in distributed arbitration. Centralized bus arbitration is a method of determining which device gets to use a shared communication bus at any given time. Imagine a bus has a road and the devices has cars waiting to drive it on that road. In centralized bus arbitration, there is a traffic cop called the bus arbiter that controls the traffic flow on the road. When a device wants to transmit data on the bus, it sends a request to the bus arbiter, just like a car driver would signal to the traffic cop to get the permission to drive. The arbiter then evaluates the request from the different devices and decides which device gets to use the bus first. It follows has set predetermined rules or priorities to make a decision. For example, let's say we have three devices: device A, device B, device C. When device A wants to transmit data, it sends a request to the bus arbiter. Then arbiter then checks if any other devices are currently using the bus. If the bus is available, the arbiter grants permission to device A and it can start transmitting its data. If transmitting data. If the bus is already being used by another device, the arbiter may be prioritize certain devices based on their importance or predefined rules to determine who gets access next. The centralized bus arbitration has some advantages. It simplifies the decision-making process since there is only one arbiter making the choice, ensures fair access to the bus, and prevents conflicts between devices trying to use the bus simultaneously. It can also become a bottleneck in system with a large number of devices has all requests needs to go through the signal arbiter, potentially causing delays. Overall, centralized bus arbitration provides a control and orderly method for a device to share a bus, ensuring that each device gets its turn to transmit data based on the decision of the bus arbiter.
Distributed bus arbitration is a method of determining which device gets to use a shared communication bus when multiple devices want to access it simultaneously. It's like having multiple cars at the intersection, and they need to decide who gets to go first without any traffic lights or traffic cop. In distributed bus arbitration, each device on the bus has the ability to request access to the bus independently without relying on central authority. When a device wants to use the bus, it sends a request signal to all other devices on the bus, just like car honking their horns to signal their intention to go. If no other device is currently using the bus, the requesting device is granted permission to use it. It's like a car or an intersection where no other cars are present, so it can proceed without any obstacles. However, if multiple devices try to access the bus at the same time, collisions may occur, similar to cars trying to enter the intersection at once. To avoid collisions, a mechanism called collision detection or avoidance is employed. This mechanism enables devices to detect if another device is already using the bus. If a collision is detected, the requesting devices need to wait for a random amount of time before attempting to access the bus again. It's like car patiently waiting for their turn to enter the intersection after a collision is avoided. Distributed bus arbitration allows for a fair and decentralized method of sharing the bus among multiple devices. It ensures that devices have equal opportunity to access the bus without relying on the central arbiter.
Methods of centralized bus arbitration. There are three bus arbitration methods. First is daisy chaining method, second is polling or rotating priority method, and third one is fixed priority or independent request method.
The first bus arbitration method is the daisy chaining method. The daisy chaining method involves connecting all the devices that can request an interrupt in a serial manner. This configuration is governed by the priority of the devices. The device with the highest priority is placed first, followed by the second highest priority device, and so on. Now, daisy chaining method is also a very simple and cheaper method since all the bus masters use the same line for making the bus requests. Also, daisy chaining method arrangement ensures that the highest priority interrupt gets served first, and it has thus established a hierarchy. The farther a device is from the first device, the lower is its priority. The following figure shows the block diagram for daisy chaining priority system. So as already mentioned before, in daisy chaining system, all the devices are connected in a serial form. Also, the interrupt line request is common to all devices. So now, if any device has interrupt signal in low level state, then interrupt line goes to the low level state and enables the interrupt input in the CPU. When there is no interrupt, the interrupt line stays in the high level state. The CPU responds to the interrupt by establishing the interrupt acknowledge line. This signal is received by the device 1 at its PI input. The acknowledged signal passes to next device through PO output only if device 1 is not requesting an interrupt. This is how this system basically works. Now we come to the advantages and disadvantages of the daisy chaining method. So the first advantage is that this method is very simple and scalable. As we have already seen that in this method, all the bus masters use the same line for making bus requests. This makes it more simple and also cheaper. Second advantage is that the user can add more devices anywhere along the chain. The first disadvantage is that the value of priority assigned to a device depends on the position of bus. We have already seen before that the farther a device is from the first device, the lower is its priority. So this is a disadvantage. The second disadvantage is that propagation delay arises in this method.
So the next bus arbitration method is the polling or rotating priority method. Like in the previous method, that is decision method, we saw that the arbiter gives priority to the devices that are closest to it. That is, it assigns priority to devices that are closest to it, followed by the devices that are far away from it. That is, it gives priority in sequence to the devices from closest to it to the farthest. So we cannot give any unique or particular priority. It only follows one priority, that is closest to farthest. To overcome that, we can use polling or rotating priority method. And here on the screen, you can see the definition of the polling or rotating priority method. The keyword here is unique priority. Because we cannot do that in daisy chaining method, that can be only done by the polling or rotating priority method. And how it works, we will see that in the block diagram. So we will jump straight to the block diagram. This is the block diagram of polling or rotating priority method. There are three major components to be understood, that are polling lines, bus request, and bus busy. By the name only, bus request and bus busy are quite evident what their functions are. Bus request is used by the devices to request for permission to the arbiter, and bus busy is used to show the status of the bus, is it busy or not. And for the polling lanes, just for now, remember that it is used for addresses, for accounting for the addresses of the devices. And now for the actual working of the polling method, we are going to compare it with the daisy chain method. Daisy chain method, we saw that if any of the devices posts a request, the arbiter starts giving permission from closest to the farthest device. That is, the arbiter passes request to D1 and D1 forwards to D2 and then D2 forwards to D3 and so on up to any number of devices. In between, any of devices that have posted the request stops forwarding the request and gets permission granted for the use of the bus. You can see there is no unique addresses to the devices. It just forwards request to the next device. But in polling method, there is unique address assigned to the every device. For example, for sake of simplicity, we are just saying that the address of the devices are D1 and D2 and D3. In reality, it would be in binary 0102 or anything that like that. Now to understand it in a better way, we are going to take an example. We are taking here example that we are pre-assigning priority of the system that the D2, D3 and D1. These devices will be accounted priority wise. D1 will be accounted first and then D3 and then D1. This thing cannot be done in the decision method. That can be only done in the polling method. Now, for example, if the bus is not busy and the any of one device is posted the request, so it will be the permission will be granted to it because no other device is using the bus. So you can say when the bus is not busy, any of the device requested for the permission, it will act as a first come first serve. But in case two devices tries to request for the permission at the same time, then the priority we assign will come into play. Like for example, if we say first the D3 post request for the permission, and it will definitely get the permission because bus is not busy initially. Then on second instance, D2 and D1 post the request at the same time. Now the now but what the arbiter will do, he will check the our pre-assigned priority. We have assigned D2 higher priority than the D1. So as soon as the process of the D3 is completed, the D2 will get the permission first, then the D1. Because in our priority list that we pre-assigned, D2 is higher than D1. That is the basic difference between daisy chain and polling. In polling, there is unique priority that we can be assigned on which the arbiter works. Based on working principle and the characteristics of polling or rotating method, there are some advantages and disadvantages of this method. The advantages are as following. This method does not favor any device. Like in daisy chain, the device closest to the arbiter was favored, given more priority than the device further. In this method, there is no favor for particular device. It will only give priority according to the pre-assigned priority list. And another advantage is that if any one of the device fails in our system, the system will keep on working. Whereas in daisy chain, if any of the system stops working, the request could not be forwarded to the next device, so the system will not work as required. Now about the disadvantages of the this method. First disadvantage is that we have to add holding lines for counting the addresses of the devices, which increases the complexity of the system. Now the another disadvantage of the polling system is that if multiple devices are posting requests, the permission will be always granted to the device having higher priority. In, in this case, the devices having lower priority will always be standing in last in the queue and will never be granted the permission.
So the next bus arbitration method is fixed priority method. In the fixed priority method, each task is assigned a priority value and the scheduler executes tasks based on their priority. The task with the highest priority is executed first, followed by the task with lower priorities. If multiple tasks have the same priority, their execution order may be determined by other factors such as arrival time or round robin schedule. So the next bus arbitration method is fixed priority method. In the fixed priority method, each task is assigned a priority value and the scheduler executes
Advantages of the fixed
tasks
priority
based
method.
on their
Simplicity.
priority.
Fixed
The
priority
task with the
scheduling is
highest
relatively
priority
simple
is
to implement.
executed
Then
first,
there comes
followed by the
determinism.
task
It
with lower
provides
priorities.
deterministic
If
behavior
multiple
where
tasks have the
the
same
tasks with
priority,
higher
their
priorities are
execution
always
order may be
executed before low
determined by
priority
other
tasks.
factors such
It
as
can also provide
arrival time
real-time
or round
guarantees as
robin
it
schedule.
can ensure that
So the
critical tasks
next
meet their
bus
timing
arbitration
deadlines if
method is
priorities are assigned
fixed priority
appropriately,
method.
thus
In the
causing
fixed
generation of a
priority
faster
method,
response time.
each task is assigned a
Coming on to the
priority value
limitations
and the
of the fixed
scheduler
priority method.
executes
First, there
tasks
is
based
priority
on their
inversion.
priority.
It
The
can suffer
task with
from
the highest
priority
priority
inversion,
is
where a low
executed
priority
first,
task
followed by
holds
the
a
task with
resource
lower
required
priorities.
by a high
If
priority
multiple
task,
tasks have
causing
the same
delays.
priority, their
Then, it can
execution order
also
may be
have an
determined by other
unpredictable
factors such
behavior.
as
If
arrival
priorities are
time
not
or round
assigned
robin schedule.
properly, lower
So
priority
the
tasks
next
may
bus
monopolize the
arbitration
processor,
method is
resulting
fixed
in missed
priority
deadlines
method. In the
for
fixed
higher
priority
priority tasks.
method, each
And the
task is assigned a
hardware cost
priority value and the
is also
scheduler
high.
executes tasks based on their priority. The task with the highest priority is
Now coming on
executed
to
first,
independent
followed
request
by the
method.
task with
The
lower
independent
priority.
request
If
method
multiple
involves
tasks have
handling
the same
resource
priority,
requests
their
from different
execution order
processes
may
or
be
tasks
determined by other
independently
factors such
without
as
strictly
arrival
priority
time
based
or round
allocation.
robin schedule.
Each process
So
makes
the
a request
next
for
bus
resources when
arbitration
needed,
method is
and the
fixed
system
priority
provides the
method. In the
requested
fixed
resources as
priority
available
method,
without
each task is
considering
assigned a
priority.
priority value and the
The
scheduler
independent request
executes
method includes the
tasks
following
based
method:
on their priority. The
resource
task with the
requests,
highest
resource
priority is
availability, and no
executed first,
preemption.
followed by the task with lower priorities. If multiple tasks have the same
The
priority,
independent
their
request method
execution order
offers
may be
flexibility
determined
in
by other
resource
factors
allocation,
such as
allowing
arrival time or
processes to
round robin
request
schedule.
resources dynamically.
So the
It
next
avoids
bus
priority inversion
arbitration
issues
method is
as the
fixed
resources are
priority
allocated
method.
based on
In the fixed
availability
priority
rather than
method,
strict
each task
priority.
is assigned a
However,
priority
it
value
may
and the
introduce
scheduler
additional
executes
complexity in resource
tasks
management
based on
and
their
may lead to
priority.
potential
The
resource
task with the
contention
highest
or
priority is
inefficient resource
executed first,
utilization.
followed by the task with lower priorities. If multiple tasks have the same priority, their
Thank you for watching
execution
this
order may
video.
be determined by
Please make
other
sure to
factors
like
such
and
as
subscribe.
arrival time or round robin schedule. So the next bus arbitration method is fixed priority method. In the